The science behind speed limits. Welcome to Blueprint to Reality, the channel where we explore the engineering and science shaping our world. Today, we'll uncover the fascinating science behind speed limits. Why are they set at specific values, and how do they impact safety and efficiency? Let's hit the road and find out. The purpose of speed limits. Speed limits serve as essential tools for maintaining order and safety on the roads. They regulate the pace of traffic to minimize collisions, manage congestion, and create a predictable flow of vehicles. Beyond safety, speed limits help preserve the condition of infrastructure, reducing wear and tear on roadways caused by excessive speeds. Moreover, they foster a sense of discipline among drivers, encouraging responsible behavior that aligns with the overall design and purpose of the road. Factors influencing speed limits. The process of determining speed limits is complex and considers a wide range of factors. Road design plays a crucial role. Straight, wide roads may allow higher limits, while winding roads or those in residential areas require lower speeds for safety. Land use is another significant factor. Areas near schools, parks, or commercial zones often have reduced speed limits to protect pedestrians and cyclists. Visibility, weather conditions, and historical accident data are also vital in establishing appropriate limits. All these considerations ensure that speed limits are tailored to the specific risks and conditions of each road. The physics of speed and safety. Physics is at the heart of why speed limits are vital. The faster a vehicle travels, the longer it takes to stop due to increased momentum and the greater the impact force during a collision. For example, at 50 kilometers per hour, a car might need 13 meters to stop after braking begins. At 100 kilometers per hour, that distance increases exponentially, often exceeding 40 meters. Additionally, higher speeds reduce the effectiveness of safety features like seatbelts and airbags. By enforcing speed limits, engineers and policymakers aim to reduce the kinetic energy involved in accidents, ultimately saving lives. The role of human behavior. Human limitations play a significant role in the science of speed limits. Reaction time, the interval between noticing a hazard and taking action, averages around 1.5 seconds. At higher speeds, this delay translates into more significant distances traveled before the driver can respond. Speed limits provide a safety buffer, ensuring that even if reaction time is slightly delayed, there's a greater chance of avoiding accidents. They also account for varied skill levels among drivers, helping ensure roads are safe for everyone, regardless of experience or reflexes. Environmental impacts of speed. Speed limits are not just about safety, they also have profound environmental implications. Vehicles traveling at higher speeds consume more fuel due to increased air resistance and engine strain. For instance, driving at 120 kilometers per hour compared to 90 kilometers per hour can increase fuel consumption by up to 20%. This additional fuel use leads to more emissions of greenhouse gases like CO2, contributing to climate change. By setting and enforcing speed limits, authorities promote not only safer but also more sustainable driving practices, helping to reduce the environmental footprint of transportation. Case studies, speed limit success stories. Several countries have demonstrated the effectiveness of well-implemented speed limits. Sweden's Vision Zero initiative focuses on designing speed limits based on road conditions and crash risks. This approach has significantly reduced road fatalities by ensuring that speed limits align with the human body's tolerance to crash impacts. Similarly, the Netherlands employs dynamic speed limits on highways, which adjust in real time based on traffic density and weather conditions. These examples highlight how scientifically determined speed limits can save lives and improve traffic efficiency. Challenges and public perception. Despite their benefits, speed limits often face resistance from drivers who view them as unnecessary restrictions. Noncompliance is common, particularly in areas with limited enforcement, where drivers may ignore limits they perceive as too low. Addressing this requires public education to explain the rationale behind speed limits and their role in preventing accidents. Technological tools like speed cameras and automated enforcement systems also play a crucial role in ensuring adherence, making roads safer for everyone. The future of speed management. As technology advances, the future of speed management looks increasingly promising. Intelligent speed adaptation systems, for instance, use GPS and sensors to automatically adjust a vehicle's speed based on the road's limit. Connected vehicles and real-time data analysis also enable the creation of adaptive speed limits that respond to weather, traffic conditions, or emergencies. These innovations aim to reduce human error and create smarter, safer roads for all users. Thank you for joining us on this in-depth look at the science behind speed limits. If you found this video insightful, don't forget to like, subscribe, and hit the bell icon for more fascinating explorations into the world of engineering and transportation. Together, let's make every journey safer and smarter. See you in the next video.